Hi there, my name is Yasmin and I am a tutor here at Tutor Impact. And today we're going to be looking at the thermoregulatory system. Don't worry if you don't know anything about this because I'm going to take you back to basics and we're going to discuss all of the features of this system and also a bit of background just for context. Now, as I said, we're going to start with some background context and look at homeostasis. You might have already heard of this word before as it's common in quite a lot of biology syllabuses, but don't worry if you've never heard of it before. So the conditions inside of our body must be carefully controlled if it's to function effectively. And homeostasis is the maintenance of a constant internal environment in the body. So it's the mechanism and the maintenance of ensuring that the internal system in our body is staying consistent and the same. And the nervous system and hormones are responsible for controlling this. Now, we're going to be specifically talking about the thermoregulatory system later, which is obviously keeping the temperature constant within the body. But we're going to look at some more general control systems first that feature in our bodies. And these, as you can see here, are the receptors, the coordination systems, centers, and the effectors. So the body control systems are all automatic. You might not know what that means, but it just means, in simple terms, that you don't have to do anything consciously for these to take place. You don't have to think about it. You don't have to actively think, oh, I need to keep my temperature the same. Your body just does all of this for you. And this involves both nervous and chemical responses. There are actually quite a lot of important parts that feature in these control systems, but the three main ones I have listed here and I've just mentioned. So firstly, receptors. What these do is they detect a stimulus, which is a change in an environment, such as a temperature change. So these act slightly like an early warning system. They detect the change. It's their job to sense that something has changed in this internal system. And what they do is they then report this. Well, I say report in a very loose term. They report this change to the coordination centers. So the coordination centers are in the brain, the spinal cord, and the pancreas. And they receive this information from the receptors, and it's their job to process the information and to work out and then instigate what response is needed. And that response usually takes place at the effectors. And these are things such as the muscles or glands, which create the response to that initial change that's detected by the receptors. So for example, the glands, they often release a hormone, which then restores the optimal condition again. However, we'll discuss sort of other functions and features later on when we discuss the thermoregulatory system. Moving on to that sort of area, we have body temperature. And as I said, this is controlled by the thermoregulatory system. And body temperature, as mentioned before, is one of the factors that is controlled during homeostasis. And this is the main sort of focus point of today's lesson. The human body has to maintain a temperature where the enzymes work best. So enzymes feature all over your body and carry out different roles, but they work best at around 37 degrees Celsius. So it's really important that the body tries to maintain that temperature at all times so that the enzymes are working at their optimal level. As I said before, this process is controlled by the thermoregulatory center, but this is actually controlled and contained in the hypothalamus in the brain. So the thermoregulatory center is contained in the brain in what is called the hypothalamus. And it contains receptors that are sensitive to the temperature of the blood. And these, as I said, are the receptors that we spoke about before that detect that initial change in environment. And here they're detecting the temperature of the blood. Your skin also has temperature receptors, so they can also send nervous impulses back to the thermoregulatory center. So we have two sort of main temperature receptors, and these are in the hypothalamus in your brain and also on the surface of your skin. We're now going to discuss sort of what happens when your body is not at that optimal temperature of 37 degrees Celsius and how it responds to that being detected. Now, first of all, we're going to discuss what happens when you get too hot. So you can see here there are two main effectors, or two main responses when it comes to being too hot. We have sweat glands releasing more sweat, and we have what is called vasodilation. So when you're too hot, sweat glands in the skin release more sweat. What this does is that sweat then evaporates, and as it evaporates, it transfers heat energy from the skin to the environment. So it removes some of that heat from your body to the environment, which in turn makes your skin, or wherever it is in your body, cool down. So sweat helps to reduce that temperature when it is too hot. The second response is when the blood vessels leading to skin capillaries, which are the capillaries on the surface of the skin, these blood vessels to these capillaries become wider. So they dilate and they become bigger. What this does is that it allows more blood to flow through towards the skin. So more blood comes up towards the surface of the skin, and this allows more heat to be lost to the environment. So more blood flows on the surface of the skin, and that means more heat is lost to the environment, which results in the body temperature going down. And this process is called vasodilation. But don't worry if that doesn't really make sense, because we're going to go through vasodilation in a bit more detail later on with a diagram, just so you properly understand it. On the flip side, we're going to look at what happens when your body gets too cold. And you can see here there are three main responses. The first one is where skeletal muscles contract rapidly and we shiver. You'll probably be able to think of a time this has happened to you, when you've been really cold and you start to shiver. What these contractions do is that they cause the muscles to rapidly contract. And these contractions need energy from respiration. And in this process, heat is released. So in the process of respiration, heat is released, which means that the temperature in the body increases because of these processes happening in your muscles. Another response that happens is similar to vasodilation, but the opposite. So blood vessels which lead to the skin capillaries become narrower. So the blood vessels that go to the capillaries on the surface of the skin, they become narrower, they constrict. This allows less blood to flow to the surface of the skin, and that means it conserves the core body temperature. So it means that less heat is being lost as the blood comes up to your surface of the skin. And this is called vasoconstriction. So this is the opposite, in effect, of vasodilation. The final response measure is your hairs on your skin. So your hairs on your skin also help to control body temperature. Usually when we're warm, these hairs lie flat against your skin, as they probably are doing right now. However, they rise up when we are cold. So when we are cold, the nervous system sends impulses to the hair erector muscles, which then in turn contract. And what this does is it raises the skin hairs on the surface of your skin, causing all of your hairs to stick up on edge. And this traps a layer of insulating air next to the skin. So it acts as an insulator to your whole body, which means you don't lose any more heat, and it conserves the heat that you already have. And this is another way of the body trying to increase its temperature. So all three of these methods try and increase the temperature in the body to try and get it back to that normal optimal level of 37 degrees Celsius. Now, we're going to look again more generally at the thermoregulatory system, and it's controlled by what is called a negative feedback mechanism. So the control of body temperature is an example of negative feedback mechanism. And this regulates the amount of shivering, so those rapid muscle contractions, the sweating, which is the evaporation of water, and the blood flowing in those skin capillaries. And this following diagram shows the process we discussed so far quite well. So here we have normal body temperature. And as we discussed initially, the body can get too hot. So it rises above 37 degrees Celsius. This is detected by the thermoreceptors, which, as we said, are located in the hypothalamus in the brain and also on your skin. What happens then is that the coordination center in the hypothalamus then sends nerve impulses to the skin, and the receptors, the effectors, which affect the response, then put those different control mechanisms in place. So you have increased sweating, you'll have vasodilation, and this causes your body to lose heat. So it decreases the overall body temperature until you end up going back to normal. Now that is the process when you are too hot. We then went on to briefly discuss what happens when you are too cold. So again, we will follow this diagram. So the temperature in the body decreases, it falls below that 37 degrees Celsius mark. This is picked up by the thermoreceptors. Again, these are in the hypothalamus and in the skin. The coordination center in the hypothalamus then coordinates what the response is and sends nerve impulses to the skin. Similarly with when you're too hot, this means the effectors then carry out the action required of them to make sure that the body temperature increases and goes back to normal. And as we discussed, these processes involve shivering, vasoconstriction, and also those hairs erecting on your skin to create that insulating layer. And the end result is that the body temperature then returns back to the optimal temperature of 37 degrees Celsius. And that is how the negative feedback system works. You can see that it goes away from its optimal, and then we have to get it back to that optimal level. Now, next, we're just going to look briefly into a bit more detail of what vasodilation and vasoconstriction are, because although I mentioned them briefly, there wasn't a visual representation which was there to help you. So we're just going to briefly go through the steps again so you can try and envisage this process. So we're going to start with vasodilation, which, as we said before, this increases body temperature. So when the thermoreceptors detects an increase in body temperature, the hypothalamus sends nerve impulses to the skin, and then vasodilation takes place. So as you can see in this diagram, the nerve impulses come from the hypothalamus and they are sent to these arterioles, which are the blood vessels which go to the capillaries. And as we discussed before, these get wider. So these arterioles increase in size, they dilate. And this allows more blood to flow through them and increases the blood going to the surface of the skin and the capillaries in the surface of the skin. So as you can see here, the arteriole has become wider, there is more blood, and it goes up and it goes all the way to the surface of the skin. You will also see that this little vessel here called the shunt vessel, this becomes narrower. So it stops more blood flowing through at a lower height, and it forces that blood to go even higher towards the surface of the skin, and then heat is lost by radiation at the surface. So that is how more blood is forced to the surface. The arteriole becomes wider, the shunt vessel becomes narrower, and the blood is forced up to the surface of the skin where heat is lost by radiation. We'll now look at the opposite, which is vasoconstriction. So if you remember correctly, this is where the body gets too cold. So when there is a decrease in body temperature, this is detected by the thermoreceptors, again in the brain and on the skin. And then these receptors send that information to the hypothalamus, which is the coordination center. And this then sends impulses to the skin, which you can again see here. So the nerve impulses from the hypothalamus travel to the arterioles. Now, the opposite situation happens to vasodilation here. Instead of becoming wider, the arterioles become constricted, so they get smaller. And you can see this here from the diagram. These arterioles become a lot thinner, they constrict to reduce the blood flow to the surface of the skin. Sorry. So less blood is going to the surface of the skin, so less heat is being lost through this blood traveling near the surface of the skin. And in turn, that shunt vessel we looked at before, in this case, it becomes wider, so it dilates. And what this means is that blood is more likely to flow through the shunt vessel, which is much lower than the surface of the skin. And then it just goes back through the vessel system. So instead of going up to the surface, it takes the lower path, which means that less heat is lost through radiation. So for vasoconstriction, the arterioles get smaller to the surface of the skin, but in turn, the shunt vessel dilates and becomes wider, which means there is less heat loss. And it means that the body can get warmer as there is less heat being lost. Now, I'm just going to quickly recap what we've spoken about today, as I know there has been quite a lot of content. So we looked at the conditions inside our body, and we know that they must carefully be controlled in order for it to function effectively. And we discussed that homeostasis is the maintenance control for ensuring there is this constant internal environment in the body. And we also looked at how the nervous system and hormones are responsible for controlling this. We then went on to look at mechanisms in the body involved in controlling the temperature. And here we discussed receptors, the coordination centers, and the effectors. We then looked at the thermoregulatory system in particular, and we looked at how the body responds when it's too hot, which includes the sweat glands releasing more sweat and vasodilation. And then we went on to look at how the body responds when it's too cold, including shivering, vasoconstriction, and your hairs standing up. And then finally, we just looked at the negative feedback system, and then we looked at vasoconstriction and vasodilation, just a bit more detail in order for you to get a good visual representation of what it is. So that's everything for now. I hope this video has been useful and that you now understand a bit more about the thermoregulatory system. Thank you so much for watching and have a good rest of your day.